MAA.
Hey guys, we're looking at a merit from complex numbers achieved from differentiation and a merit from integration. Okay, let's get going. By the way, I just asked how many of you guys know this question, and pretty much how many have we had? We had quite a few people put their hands up. Now, one of the things you guys need to understand about complex numbers is this little thing that you see here. All right, they'll have these two big lines, and then they'll have Z. What it means is it's actually asking you for modulus of Z. So you're actually looking for literally the R value of this. So when you see 3 plus I divided by 2 minus I, what you need to do is you need to write it as a complex number, like you got to have
A plus B.
yeah, you need to write it as A plus BI. So the first thing I'm going to do is, because this is 3 plus I and 2 minus I, what I can do is I multiply it by the conjugate of it, which is 2 plus I and 2 plus I, which means my numerator now is going to be 6 plus 5I plus I squared, and that's divided by, is that 5I there? Have I got that right? 2 plus I, yep, that looks right. And then at the denominator, I'm going to have 2 minus I squared. Is that all right? Have I done anything wrong there?
2 squared.
2 squared, thank you very much. See, someone always mess it up. All right, so then we have 6 plus 5I minus 1 divided by 4 minus 1. So this could be written as 5 plus 5I divided by 5. Is that okay so far? So this complex number now can be written as 1 plus 1I, because that's just simplified. Is that okay? Now, if I give you this complex number, 1 plus 1I, what would the modulus be for this? Yep, because if I was to draw this, 1 plus 1I, so that's 1 there, that's 1I, it's going to be there, and I'm looking for the modulus of this. So I've got 1 as the base of my triangle, 1 as the height of my triangle, and r squared, which is modulus, is 1 squared plus 1 squared. R squared equals 2, therefore r is equal to square root of 2. So that's all it means is like this symbol that you're looking here, it basically just means find the modulus of. That's all they're asking you to find, which is that hypotenuse part of the Pythagoras theorem. So to get a merit in this question, you needed to prove this part here. To get to an achieved, had you done simplified quotient, so had you done it up to here, you could have still walked away with an achieved. Now I know that you guys, we saw this very briefly when we did modulus and argument last term, but it's just putting it all together now, that's all. So if I give you another question like this now, I think you guys will be all right. Am I correct? Okay, that's good enough for me. Should we go to the next question? Okay, so the next question was looking at differentiation. Now I actually chose an achieved question because I was just trying to get through all of our questions in 2012, and yeah, so this was one of them. So in this question, you've been given a velocity function, which is this here, and all they're asking you is find the times at which the object's acceleration is 0. So if you have velocity, which is 2t 36 plus t squared, to find acceleration, you need to do differentiation of velocity. Now looking at velocity in this function, well with this, what are you going to use to differentiate? What rule? Quotient rule, thank you. So if we're using quotient rule, I'm going to use f and g. If I put f equals to 2t, f dash equals 2, and then if I put g equals 36 plus t squared, g dash equals 2t. So now I can write accelerations is the differentiation of velocity, which is f dash g, and then plus f g dash, and that's whole thing is divided by g squared. So acceleration equals 2t multiplied by 36 plus t squared. Let me know if anything's happening wrong, guys. Have I done something wrong? I think I have 2t. That should be 2, right? Yep, there we go. And also that should not be a plus. That should be a minus there. Man, I need some sleep. All right, 2t, and then g dash is also 2t. Is that okay? And the whole thing is divided by 36 plus t squared to the power of 2. Now, they're asking you to find when acceleration equals to 0, so I can put this whole thing equals to 0. Now, the other thing I could also do is, if a number is being divided by another number, for it to equal 0, only the numerator has to be 0. Okay, so only this part needs to be 0, because when I bring this across to the left-hand side, it becomes 0. So I'm left over with 0 equals 2 times 36 plus t squared minus 4t squared. And simplifying this, I'm going to get 72 plus 2t squared minus 4t squared equals 0. So 0 equals 72 minus 2t squared. All right, at this point, rearranging and writing this, I get 2t squared equals 72, t squared equals 36. Therefore, t is equal to plus or minus 6. But I think in this question, we just look at the positive value, because we just say that t, well, I mean, you can say it happened 6 seconds before from the start, but we'll just leave it as t equals 6 seconds. Is that all right? So this comes out to be achieved. Differentiating it and putting it equals to 0 and solving it. Any questions? Straightforward? All right, let's go to integration. This was the one that I sent you guys by mistake yesterday. Like I repeated the question, but hopefully you got a chance to have a look at it. So what we have is we have a function that's been given to us, and they're asking you to find what this blue area is. Now, to differentiate, so we look at it, we've got it, this is between 6 and 2. We have 4x minus 1 and x plus 3 dx. Now remember that when you have two x's at the top in the numerator and the denominator, I mean, my way of doing this is doing long division first, and then writing them as like two separate fractions. So I'm going to have x minus 3, and I'm going to have 4x minus 1. So this is 4, I've got 4x minus 12. Subtracting it, negative 1 minus 12 is going to make it positive 11. So how do we write this, guys? Do we write it like this? 4 plus 11 over x plus 3. Is that 11 or 13? I copied the question. Oh, sorry. I've copied that wrong. Okay. So that should be x plus 3. That should be plus 3. So negative 1 plus 12 is negative 13. Is that right?
It's hard to say.
Yeah. So that's not positive 11. That's minus 13. Is that okay? Thank you for keeping me awake. All right. So once we've got this part, now we can actually start differentiating it. So we're going to get 4x minus 13 ln of x plus 3. Don't have to worry about the plus c part, and that's between 4 and 2. And also we don't need to worry about dividing by dividing by the differentiation of this, because that's just 1. So really don't need to worry about that 1 there. So we're just going to leave it as it is. Now it's just a matter of substituting it. So we have 4 times 4 minus 13. Wow, jeez. I've been making videos non-stop for the last, like, literally 12 hours. So, okay, so where was my 6? There. 4 times 6. 13, 6 plus 3. Let me see if I can finish this off properly. Minus 4 times 2 minus 13 ln of, what do we got? 2 plus 3?
Yeah.
There we go. Yep, so basically from this point onwards, guys, it's just a matter of putting this in your calculator and getting an answer for this. So you do get 8.359. So in terms of merit and achieved, you've got merit here. And for achieved, it's your actual integral, which is this part here. Now remember, I told you guys how you can do this in the graphics calculator. So what you really should be doing is go from here to here. You need to show it, show the working, and then from here to this point, just do it in the graphics calculator to get your answer and just chuck it in. Don't waste time, and especially when you're sleepy like me, like you'll make silly mistakes like what I did. Okay? Just make sure you get that integration right, and then make sure you can get the final answer right. Questions? Straightforward? All right, that's us for today. Thank you.